Hi, I'm Dave Fornell, the editor of Diagnostic and Interventional Cardiology magazine. I'm here at TCT 2015 in San Francisco, and one of the key trials that came out at TCT this year was the Absorb-3 trial, Bioresorbable Stent produced by Abbott, and this is the pivotal trial that is going for FDA. And another innovation in bioresorbable technologies was the Boston Scientific Synergy Stent. And I have with me today Dean Kereiakes. He's the medical director of the Christ Hospital Heart and Vascular Center, and you were the lead investigator, or a lead investigator, with both the Absorb-3 and also with the Synergy pivotal trial.
Right.
So tell us a little bit, the short version of what you presented with the Absorb-3 data here at TCT.
Well, you know, it's a pivotal trial for FDA approval. It is randomized 2-to-1. Primary endpoint is target lesion failure, which is a component of cardiac death, target vessel-related MI, and ischemia-driven target lesion revascularization at 1 year. And it was randomized against the best-in-class DES. Yeah, it's a high bar. I mean, this is not a low bar. So this is, you know, and again, the best performing current metal platform DES that we have. That's what we went up against for an endpoint at 1 year, even though BVS is specifically designed to improve outcomes beyond 1 year because it will go away at a time when the metallic platform still has issues with incomplete healing, fracture, neoatherosclerosis, and other issues that contribute to 2 to 3% per year device-related events beyond 1 year with the best current metal platform. So the real test in the long run is, does the Absorb BVS, the bioresorbable vascular scaffold, improve late outcomes when it's gone and shouldn't be complicated by those issues compared to the metal platform. But to get it on the market, to get it approved, you have to show reasonable safety and efficacy and comparable safety and efficacy within the first year.
And within the margins that you had, there was no significant statistical difference between the outcomes for these stents, slide by slide, when you went through those presentations.
That margin was predefined in collaboration with the FDA, and I think also in agreement with the FDA document on non-inferiority trials. And so we were conservative, I think, in the non-inferiority margin that was picked.
I know that there were some critics that came out and they said, if you take a look at the BVS, the Absorb stent, that there were slightly higher numbers, not statistically significant because of the numbers in the power of this trial. But if you were to trend that out, there might have been some sort of a signal if you had more patients. But my understanding with this stent technology is that you can look at whatever you want right now, but what you really want to look at is 3 to 5 years from now when that stent has disappeared from the vessel.
You absolutely do. We have 2,008 patients in our trial that were randomized, and then we're going to add 3,000 patients with Absorb-4. 5,000 total patients followed through 5 years. And of course, the primary endpoint in Absorb-4 will be landmark year 1 to 5, target lesion failure between Science and Absorb, BVS. But I think at this point, you know, the device did what it was set to do. The study was designed appropriately. There was nothing unusual about this. It's quite similar to the other trial, Evolve-2, that I was the PI in, with an 8% TLF, a 4.4% non-inferiority margin. These are all quite similar and in design. I call it a cookie cutter design. And, you know, maybe that's not the right word for it, but it works. You get 2,000 patients, between 1,500, 2,000 patients, you randomize, and you show it's not inferior within a predefined margin.
So with the current generation of DES, the stent strut size is about 80 microns.
Yeah, it's 81 microns. The polymer, the PVDF polymer, is 7.8 microns on average, and the BVS is 150 microns. And it has a total of 7. Yeah, it's very similar to Cypher. Cypher was, the strut thickness was 55 thousandths of an inch. This is 59 thousandths, so it's just a little larger than Cypher overall. It's wider too, not just thicker, but wider. So the footprint, so to speak, is a large footprint, and that's one of the things that Abbott is fast down the path. They've already got the next generation, 33% thinner strut. It comes in under 100 microns. And I think you're going to see just overall better performance, because strut thickness is not really a positive thing as far as acute performance, the deliverability, profile, but also as far as issues like scaffold thrombosis.
So you did a sub-analysis of the 2.5 and smaller vessels with this trial, and because of those larger struts, what did you run into?
You know, that's very interesting. You would think, and this is 2.5 as treated, so it's 2.5 BVS scaffold, 2.5 Xience. And the TLF rates were 8.5 and 9.3. Actually a little numerically less with BVS. Each component of TLF not significantly different, but when you stratify the 2.5 analysis as treated by reference vessel diameter less than 2.25, you see an apparent hazard for target lesion failure, target vessel MI, scaffold thrombosis with the thicker strut device, as you might expect, cramming a thicker, wider strut into a confine, smaller confine. But when you are 2.25 or greater, Dave, which are the vessels that should have been, they're appropriate for enrollment, believe it or not, BVS is numerically less than Xience in each one of those outcomes. Now, I'm not going to ascertain or allege that BVS 2.5 is better than Xience 2.5, but what I'm going to say that I think is appropriate in appropriately sized vessels, that's 2.25 millimeters or greater, that were appropriate for this trial, the BVS does very well. The 2.5 BVS does very, very well.
And if I could get you to speculate a little bit, if this trial was run 5 years ago or 8 years ago and it was run against either the Cypher or the Taxus, where do you think things would have ended up statistically? I
think it'd be a lot closer. I think that when every analysis that you look at, there are head-on trials. There are network meta-analyses, Paul Marini, Bangalore, Kang, Navarrese. The Cypher is actually beat by Xience, EES, in multiple categories. You know, whether you're looking at target vessel revascularization, myocardial infarction, and particularly stent thrombosis, Xience is a better performing device. So we went up against a very high bar for a relatively short term, 1 year outcome. When you look at the design of BVS, which is specifically engineered to improve late outcomes.
And I think the message that you tried to project and Dr. Ellis tried to project at TCT is that while this data is good, really what you want to see is the long-term outcomes in 3 to 5 years.
Yeah, and I think that's why if I were to get a stent, I would want a device, I think, that would do its job and go away because of the issues, the lingering issues related to a permanent scaffold, permanent platform. And in also the, quote, caging effect that it has on a vessel. And I said this to somebody else the other day, that I think there's only one way for a vessel with a metallic cage in it to go, either through neoatherosclerosis, thrombosis, or scar tissue formation. It's going to go the wrong way. It's going to be narrow. It's never going to go this way. And our coronaries have adaptive remodeling. You know, one of the beautiful things is you can increase the capacity of your artery by 40% to stuff it with, if you will, cholesterol, other things that can happen to us before it really narrows, the Glagoff phenomenon. And you lose that protective, I think, beneficial capacity for adaptive remodeling when you cage the artery.
So the Absorb 3 trial, pivotal for the Absorb BVS, and we're looking at FDA approval potentially in the next year. And
I hope so. Yeah.
The other stent that was big on the agenda here at TCT 15 was the Synergy. The Synergy is a metallic stent.
It is.
And it uses a bioresorbable polymer as a drug carrier. So after you have the elution of the drug, it disappears within 3 months, and you're left with a bare metal stent. And that just got approval last week. Yeah,
it did. It's approved by the FDA, and the concept that it turns into a bare metal stent, I think, is not correct, and let me say why. It's a thin strut. It's 29 thousandths of an inch. It's a very high performance device as far as doing complex cases. It's low profile, flexible, deliverable. The polymer goes away in 3 to 4 months. The drug is eluted, and there's a little endoluminal mural depot in the wall of the artery of drug that lingers as the polymer is finally resolved. The entire device has been designed specifically to accelerate or expedite healing, okay? And the OCT data that you saw a lot of here really suggests that within 2 to 3 months of placing Synergy, there's over 90% stent coverage. which is a predictor of good outcomes. In fact, there'll be a multi-thousand patient short DAP trial, of 3 months with Synergy to test this with Laura Mori as a principal investigator. So I think this is a real significant advance, for a workhorse everyday device, and I think it will have, I believe it's specifically designed to, and it will demonstrate safety. We saw only 3 stent thromboses in our entire trial in a Synergy-treated patient, and no definite stent thrombosis after the first 24 hours. One of the only 2 definite stent thrombosis in a Synergy-treated patient never got aspirin before their procedure. So it's, those things happen in big studies. But so I think it's safe, it's very deliverable, and I think it is really not a metal platform because that doesn't take into account the anti-inflammatory, anti-proliferative, anti-atherosclerotic effects of everolimus itself, which are there for 3 to 4 months and really set the stage. It doesn't take into account specific attributes of platinum chrome, which has been demonstrated in preclinical work to reduce platelet adhesion and activation, to accelerate healing. Actually, the time course and extent of endothelial coverage was actually better in an experiment done by Epiheimer, published in Circ Cardiovascular Interventions, than it was with platinum chrome covered by best-in-class PVDF polymer. So bare platinum chrome, quote unquote, was actually better than the PVDF polymer in a cell assay. All right, but so I think there's a lot of attributes that is short-sighted to say it's just, and I'm not critical, but I've heard this many, many times. The polymer goes away, it becomes a bare metal stent. That is really not the case.
But you do lose the polymer. For,
well, I might say the same thing at bioabsorbables. Do your job and go away. And I like the concept, whether it's for polymer only or whether it's for the whole platform. It makes a lot of sense.
And the excitement probably with Synergy will also be results in another 3 to 5 years.
Well, sure, it's randomized, but it's not powered, and there's no 3,000 more patients that are being added. So we're not going to have reliable data in late outcomes because every year it gets less power. You see what I mean? And we had 1,684 patients that we randomized 1-to-1, so it's about 840 patients in each group. But over time, that's not going to, even if it showed benefit one way or the other. But we may get some good insights, I'll give it that.
Well, I appreciate your time. Thank you very much.
Really a pleasure. Thanks.
Thank you.